What's up, guys? Today's class, we shall talk about thermodynamics as you guys were asking about that. Fine. Uh, First of all, I mean, very jovial this chapter is, to be honest, because the reason I'm trying to use the word jovial is because um, every time you think about this chapter is always there in physics as well as chemistry when it comes to first year. Fine. What are we doing right now? We're doing the chemistry version of it, thermodynamics. Okay. The reason I've given some space between both of them is they have two meanings. Thermo always talks about heat and heat only. Dynamics is changes. Fine. Now, what and all to learn? I think I'll take 3 classes and to finish this off. And also, let me tell you one thing. From September 20th onwards or so, we'll start up with the offline classes. Okay. I'll let you know the exact date, but till then, and moreover, the reason I'm going to send this recording is please download this onto your computers and keep, because this is a chapter where you tend to forget a lot of things. Again, can't blame you guys because of the same chapters in two different concepts, two different subjects. Let's get into it. What are all are supposed to learn? Today's class, I'll cover all the basics. Tomorrow, a day after tomorrow's class, the derivations and all the important questions, and later, whatever numericals, if it is required. Fine. So to start off, we're supposed to learn the meaning of a system and something called a surrounding. Never learn both of them separately. Learn both of them always together. For example, let's say I'm trying to work on a thermal flask right now. Thermal flask I'm trying to work on. So according to me, during this specific experiment, all I focus is on the flask. Therefore, that will be called as a system. Anything apart from the flask will be called as the surrounding. Okay. Anything apart from the flask will be called as the surrounding. So whatever you guys are focusing on at this point of time, you're watching only this video on thermodynamics. Is it the only chapter in chemistry for your exam? No. Okay. But at this point of time, this is the only chapter which you guys are focusing on. So this will become a system. Everything else will become your surrounding. There's one more famous question. System plus surrounding gives us what? Always gives us the universe. Okay. So system plus surrounding gives us the universe. Remember this. So system is whatever we are working on at this point of time. Surrounding is whatever is not required for us. You should never include the system. You should never learn system and surrounding separately. Always learn them together. Now, next concept talks about what are the types of systems, because it's like our apparatus. What are we trying to work on? So first type is something called as open system. Very important for you guys to remember this, because tomorrow's class, when I start off with all these so basically this by this week I'll finish off this chapter. So tomorrow's class, when I start off with all these processes, isothermal process, adiabatic process, if within a flow I keep on telling it's an open system, it's a closed system, you will not know the meaning of it if you're not watching today's, if you're not able to understand this. So simple language. Open system is where exchange is possible. Okay. Exchange is possible. Now, what are we trying to exchange when it comes to open system? Two things. One is we are trying to exchange mass and energy. When both the things are able to get exchanged in a much more easier way, with the whom? With the surrounding. With the surrounding. So let's say I try to take about some random container where it has water, which is hot. Fine. So let's say the water vapor and all these things has access to the surrounding. So if it has access, what should have access? Both mass as well as energy. If it has access to the surrounding, then it is called as an open system. Simple. Next, the next type of system will be called as closed system. Now, under closed system, there are again two types. One is called as your regular closed system. The other one is called as an isolated system. Understand? Closed system in the sense, let's take the same tumbler. In the same tumbler, I'm just going to keep a plate on it. Okay. Now, what does this mean? It means that after some point of time, mass does not get exchanged. Energy is getting exchanged. Okay. This is only a closed system. What happens? In open system, both mass as well as energy was getting exchanged. In a closed system, only energy is getting exchanged. There is absolutely zero transfer of mass. But let's say I try to take an isolated chamber. In the chamber, I place a bottle or a tumbler. Then I'm going to place a cap on this. Whatever happens, this is also called as an insulation or an insulator. In this case, insulation. In this case, nothing is being transferred. Okay, so no mass is being transferred or no energy is being transferred. So this will be called as an isolated system. Isolated also comes under something called as flow system. It's a type of flow system. Understand? Open meaning both of them can be exchanged with the home, with the surrounding. Next one is closed system meaning only energy, no mass transfer. Isolated, nothing is being transferred. This is the concept. Now, there's something called as intrinsic properties, extrinsic properties. All those things are not at all required. The most important things are the types of processes. Please focus for this. Very, very, very important. In fact, I'll take so much. This will be end of today's class. Okay, once I finish this, but you'll see that I'm going to take a good amount of time to finish this. First type of process is called as isothermal. Guys, it is never about trying to understand it. It is always about how much you're able to remember it. Now, how to remember? I'll tell you. Iso meaning no change, no change. Okay, how do I know this? Isolation meaning there was no change, same concept. Iso meaning no change, thermal meaning heat. So there is no heat transfer. Okay. If there is no heat transfer, can I call this as heat remains constant? Heat remains constant. When during the exchange, there is no transfer of heat, or in simple language, heat always remains a constant. This type of process is called as isothermal process. Don't mug it up. Understand the meaning of it. Iso, no change. Thermal, heat, no change in heat. In other language, heat remains constant throughout the process. First one, very, very, very important. Second one, adiabatic or adiabatic, whatever you guys are comfortable with. Adiabatic processes. Now, what is happening here? This means it's a process where heat again. Why only heat? What does the chapter's name say? Thermodynamics. That's why only heat. Heat neither enters nor leaves. No exit, no entry. The system, okay, is called as adiabatic process. Understand? Let's go back to this. Here, do you think something is entering? No. So is something leaving? No. This is an isolated process. Okay, also called as adiabatic process. So nothing is entering the system, nothing is leaving the system. So it's like I am like this. I am not gonna change. I am not gonna ask. I'm also not gonna ask others to change. I'm just gonna mind my own business. Minding my own business is always adiabatic in nature. Remember this. Fine. I do not. I do not encourage others to do new things. I also won't do new things. I am completely fine with it. There's nothing wrong in it, guys. I am completely fine with it. This concept of being of not changing or of not asking others to change also or minding our own business is called as adiabatic in nature. Please remember it in terms of stories. Okay, no entry, no exit. I do not want more people in my life. I don't want the people in my life to leave away. So it's the same thing. I'll try not to change. That's the process of adiabatic. Okay, isothermal done, adiabatic done. Next, isobaric and isochoric. Now, isobaric, again, there is no hyphens. That's what I'm trying to explain here. Iso meaning no change. Now, usually we use the unit bar to represent what? Pressure. When atmosphere, bar, and all those things. So here, if there is no pressure change, or in other language, pressure remains constant throughout the process. Pressure remains constant throughout the process. This concept is called as isobaric process. Similarly, isochoric process means no change in the what? In the volume. Fine. So if you observe properly, we're talking about temperature. We're talking about nothing happening here. I'm not going to write any formula here at this point of time. Not required. Formula not required at this point of time. Next, I'll write. Next here, I'm talking about pressure. I'm talking about volume. In simple language, I'm talking about PVT. Okay, PVT, pressure, volume, and temperature. If there is no change in pressure, it's called as isobaric process. If there is no change in volume, it's called as isochoric process. If there's no change in temperature, it's called as isothermal process. Okay, no change meaning pressure remains constant, volume remains constant, as well as temperature remains constant. All these three letters have a significant meaning, and these are called as isobaric, isochoric, as well as isothermal processes. If I am not ready to change, I am happy with whatever I am. It's called as adiabatic process. I do not encourage other people to enter my life. I do not want people to live my life also. This is the same concept. Next, apart from this, these are the four main types. Along with this, you have two more types called as reversible reactions as well as irreversible reactions. This is not what you guys learned in chemistry in a 10th standard because it was only it's a reaction, but here it's a complete process, reversible process as well as a irreversible process. So always understand reversible process is where so basically we're supposed to talk about something called as equilibrium. Equilibrium is what every process tries to attain. Okay, that trying to attain that equilibrium is what keeps the process going. But understand, if by chance, let's say a plus b is reversible in nature to give C plus D. A plus D are combining called as reactants to form products. At some point of time, they'll attain equilibrium. The moment products become more, it happens in the backward direction. Why? To again attain equilibrium. So this is possible only in a reversible process. This is not possible in a irreversible process. Okay. All these things are important. Now, irreversible also I extend off. Okay. Where reactants are trying to form products, but they attained equilibrium and the products are completely satisfied, which means if the products are completely satisfied, they do not want to become reactants again. If they want to become reactants again, it means that the equilibrium is always shifting. Fine. So I can't talk more about this at this point of time because there's a separate chapter also called as equilibrium. And moreover, these two topics are in a much more deeper way in tomorrow's class. That's why. Next, what has to be learnt about? Fine. Most important thing here is signs. I'll talk about a small concept called as heat. Everybody knows heat is represented by Q. Now, plus sign, negative sign always plays a very, very, very important role in this specific concept. Please understand as to how it works. So I'll write signs here. Okay. So let's say if I write plus Q, my bad, don't write positive Q. If I write plus Q and minus Q, what is the meaning of it? Where is the transfer happening from? From whom to whom? Okay. Always understand. When the heat is given by the system to the surrounding, it is negative. System to surrounding. Okay. I'll go back to the first slide. This is your system. If the system is giving to the surrounding, okay, then it is called as negative because you are experimenting on something. Think from, guys, always think from system's perspective because what you care about is only the system. So think from the system's perspective. Heat is being, okay, you are losing heat, which means heat is moving from you to the atmosphere. You are losing something. Losing always means negative. Okay, next. Plus Q meaning obviously the opposite. So let's say if the heat transfer is from the surrounding to the system, don't mug it up. Okay, listen, I'll tell you. Always keep the system in mind. If heat is entering the system, it's called plus Q. If heat is leaving the system, it's called minus Q. That's all. Fine. So think of yourself as a system. If money is leaving you, you are becoming more negative in terms of bank balance. Example. Okay. If money is entering your account, it's becoming more positive. How? You thought about bank as an example, bank account as an example, because bank account was a system. Fine. Next. We'll talk about work. Just like heat, we're supposed to talk about work also, because work also plays a very important role in this chapter. Work is represented by W. Now, when will it be positive work? When will it be negative work? 1 minute. It's very important for us to understand. Now, system and surrounding is what we spoke about. Think for a second. If you're trying to do some work on the system, again, why? System is my perspective. System is what I care for. Fine. If you're doing work on it, it means you're trying to improve it. Okay, cool. We'll accept it. If you're trying to improve it, it's always positive. So it's called positive plus Q. Now, but there'll also be some point of time where the system does the work. Okay. System has to do the work. That in that case is negative. So if it is by the system, so just imagine you're trying to run. Okay. Two things. One, you're trying to run. One, you're trying to get a massage or a physiotherapy. Okay. So basically here in physio, work is being done on you to get stronger. So plus W. When you're trying to run, you are doing the work, which means the person is doing the work. In other language, work is done by the system. So therefore it is negative. Understand in terms of stories, or else after some point of time, you'll start tripping over it. You won't understand what's happening at all. Fine. Next concept. Work done and heat done. Very important. Again, what's the whole concept? System is my whole concept. Next is, let's talk about internal energy. Internal energy is represented always by U. Please understand this concept. Fine. Now, how do we define it? So realize everybody will have some kind of internal energy. The reason I'm able to talk is because the food which I ate got converted in terms of ATP, and that ATP molecule is what I'm trying to use to convert my knowledge into this specific recording, and you guys are able to listen to it. So it's a complete process here. So what's actually happening here is it is the sum of all energies. Example, kinetic energy, attraction, repulsion, that energy, this energy, subatomic particle, and all the other forms of energy inside me is called as internal energy, not outside, internal. Fine. My knowledge, your understanding, all these things is inside you. Fine. So internal energy is always you. It is the sum of all the energies present inside you. UKE, UPE, your knowledge, a number of things. So internal energy can be atomic also, subatomic particles, subatomic. All these things put together will be represented by something called as internal energy, U. Okay, very, very, very important. Now, this is the whole concept of whatever is required. Apart from this, we start off with laws of thermodynamics. The first law is very important. Laws. First, just like Newton's law, these are also are important, but it is very easy to understand also. I'll first explain the meaning of the first law of thermodynamics. Let's see what they're trying to tell. I'll read it for you guys. It says that the total amount of energy of the system and its surrounding is a constant. This is what they tell. But I am against this specific way of defining. I'll tell you a very easy way to remember first law of thermodynamics. Easiest way. Complete the statement for me. Statement for me. Energy can neither be created nor be destroyed, but can be what? Converted from one form to another. That is nothing but first law of thermodynamics. Will you get marks? Will get full marks. Okay, you'll get full marks. But how do you explain the energy conversion for them in terms of formula? So you'll write the definition. Energy is neither created nor been destroyed, but can be converted from one form to another. How do you explain the answer? Very simple formula. Write delta U. Delta always means change. So change in U meaning internal energy is equal to Q minus W. This is how we represent the formula. Q means heat, W means work. I hope you realize as to why I spoke about heat and work right now, because in order to give you that build up to first law of thermodynamics, you're supposed to know the meaning of Q as to what is positive Q, what is negative Q, what is positive work, what is negative work, and based on this we come up with the first law of thermodynamics, where the statement is very simple, but the formula depends on all the three letters delta U. But if you write U is equal to Q minus W, the answer is wrong. Delta U, it's always the change. Okay, it's always the change. So understand, delta U is equal to Q minus W, which means the change in internal energy is equal to, I repeat that, change in internal energy is equal to the difference of, heat minus work done. Now, let's say in this case, let's assume if the work is done on the system, in that case, okay, let's say on the system, if the work is done, somebody is working on you for you to improve, which means you'll become positive. So in that case, delta U will be equal to Q plus W. Okay, Q plus W. So let's say if the work is done by the system, then what will happen? Again, I'm talking about work by the system, meaning it will be delta U is equal to Q minus W. So you should not tell, sir, it's the same. No, it's the same. I realize that, but understand the statement. If the question says the work is done on the system, then the W should become positive. If the work is done by the system, then the W should become negative. Keep all these things in mind. Please watch this video again, because tomorrow's class will start something called as enthalpy. I do not want to start that right now, because right now we learn first law of thermodynamics. Whatever was done in today's class, we'll compress it with the next within the for the first 5 minutes of tomorrow's class. Then learn something called as enthalpy as well as entropy. Tomorrow's class, very, very, very important. Okay, you will get a 3-marker derivation based on it and all those things. You'll also get you'll also solve. You'll also get one 3-marker numerical. But for all these things, please don't, again, without today's class, I won't be able to explain anything with respect to tomorrow's class, because tomorrow I'll be like, work is done on the system. Heat is released by the system. I'll be so fast. So by that time you process it plus Q or minus Q, it should not take some time. So right now, up till first law, learn it. Tomorrow, what are we trying to learn? We're trying to learn a 3-marker derivation. We're trying to learn a 3-marker numerical, which will for sure come. 3-marker derivation, 3-marker numerical, and definition of enthalpy. Entropy not required tomorrow. I'll give a start to entropy. I won't define, because numericals only will take some time. Entropy. And so tomorrow approximately we get around 8 marks. 8 marks of content. But in today's class, you only got around 3 marks of content. But these 3 marks, without these 3 marks, scoring this 8 marks is impossible. So today's class is about 3 marks of content. Learn it properly. Tomorrow's class will do 8. So totally it'll become of 11. Okay. I will do the numericals tomorrow as well. So make sure you guys attend it. Fine. Tomorrow's numerical is not like apply the formula, get the answer. It's more of a logic. It's more of trying to understand the word problem wise. What are they trying to tell me? How can I balance it? How can I use on the system or by the system in terms of signs? All these things will be there in tomorrow's class. A lot of rules are there. So don't, make sure you guys don't ignore today's class, and watch this again. If you feel like nothing was going into your head, watch it again. What I want you guys to understand is this: signs, reversible, irreversible, these four processes. If I'm able to, if I use the word adiabatic, you should realize nothing is changing in the system. No heat, or there's nothing entering, there's nothing exiting. This should come to your mind the moment I use the word adiabatic. Okay. The moment I use the word isothermal, you should not know what is isothermal. You should be like, okay, this is a process where heat remains constant. Heat remains constant, meaning there is no movement of heat. Movement is very important. Okay. But tomorrow's class, I won't tell all these things. I'll just use the word isothermal. Reason is because the question will tell the given reactions represent isothermal process, isobaric process, or work done on the system by the system. So this is the concept. Fine. Make sure you watch today's video twice before coming up to tomorrow's class. Okay. See you.